Welcome to Brain Vision.
Now for this question, we have a pendulum that is swinging, and but we have an addition of a peg, right? That actually is in the middle, so that when the rope swings, when the pendulum swings across the peg, the strings get caught by the peg, and only a small amount of the string is allowed to oscillate. Now, in the case where the pendulum is released from a position that's lower than the peg, right, we know that it will return back to the same height because when it swings over, right, the gravitational potential energy is converted to kinetic energy, and as it moves further, the peg doesn't do any work to the pendulum, and energy must still be conserved. So the gravitational potential energy that it gains can only be the same amount, right, which is the same amount of height with respect to the reference point. So suppose this is the reference point, then if we are released from this amount of height h, it will only go up to this amount of height. Right, and before of course going back down and going back to the same position. So in that sense, there's no change in the height of the pendulum. Now what happens if the pendulum is released from a horizontal position? Right, so that is in this manner. Right, so it's way above the peg. We want to find what is the minimum value of d, which is the distance the peg is away from the axis of rotation, such that the pendulum is actually able to rotate a full circle around the peg. So you want it to reach this particular position. Now, in order for this to occur, it means that the centripetal acceleration at the top of this circular motion, right, this circular motion over here, at the top, the acceleration must be at least equal to gravity. So v squared over r is equals to gravity. Now r, in this case, the radius of this circle, is equals to L minus d, right, where L is the total length and d is the length between the axis and the peg. This is d. This is what we want to find, and r is equals to L minus d. So rearranging this, we get v squared to be equals to g times L minus d. Now what is v squared? Right, so we know that by conservation of energy, when the ball is released from rest, it is has a potential energy of mg times L, right? Taking reference point to be over here. On the other hand, when it is at the top of the cycle, the amount of potential energy is mg times L minus L minus d times 2, right? Because L minus d would just be this distance, but this is the radius. We want 2 times of the radius, right? The height is 2 times the radius, so it's actually L minus d times 2. And this, by energy conservation, the remaining amount of energy must have been converted into kinetic energy. Right? So mgl minus this mgl minus d times 2 must be equals to the kinetic energy, half mv squared at this point. And we know that v squared is equals to this value, so we can actually put that in. Rearranging this equation a little bit, we bring this term over to the right hand side. This is just 2 times of this term, whereas this is half of the same term. So in all, mgl is equals to alright, so we want to find what is d, so we divide by mg and we bring the 2/5 over to the other side. So d is equals to 3/5 times L.